Usually, when we talk about a medical diagnosis, there's this like expectation of precision, right? It's almost like engineering.
Oh, absolutely. Yeah, it's very binary.
Yeah.
Broken or not broken, clean cut.
Right. You break your arm, they take an x-ray, you see that little jagged white line, and the doctor just points to it and says, there it is. Problem identified.
Exactly. It's right there in front of you.
But if you step into the world of intimate wellness and like cellular biology, suddenly that x-ray machine is just totally useless. I mean, we are looking at a diagnostic landscape today that is the absolute definition of muddy waters.
Yeah, muddy is definitely the right word for it.
So for this deep dive, I want to ask you a question. What if I told you that the very products you buy at the pharmacy, the ones explicitly designed and marketed to soothe, hydrate, and protect your most sensitive, delicate mucosal tissues, what if those were actually engineered in a way that actively dries them out?
I mean, it sounds completely counterintuitive, right?
Huh?
But the biology behind this contradiction is actually incredibly well documented.
Which is wild. So we're looking at medical guidelines from the World Health Organization, some dermatological breakdowns on the skin rebound effect, and these really deep in the weeds biological studies on mucosal cell health.
Yeah, and even joint lubrication, actually.
Right. Right. So our mission today is to explore the science of osmolality, to figure out if the chronic overapplication of water-based lubricants with high osmolality can create this rebound effect that just actively dehydrates your mucosal cells.
Okay, let's unpack this. We got to start with osmolality, right?
Yeah, osmolality is really the fundamental metric here. Basically, it's a measure of the concentration of dissolved particles.
Like solutes.
Exactly, solutes. So salts, sugars, glycols per kilogram of water, which is the solvent.
Okay, got it.
So before we can understand how a product might cause a dehydrating effect, we first have to understand this sort of invisible tug of war happening at the cellular level whenever any liquid touches the body.
Right, because cells are always trying to balance things out, right? Exactly. The cells lining the vaginal walls, the epithelial cells, they're constantly trying to maintain homeostasis with their environment. Water moves really freely across the cell membrane to balance the concentration of these dissolved particles inside the cell with whatever's outside the cell.
So any liquid you introduce to that environment just instantly triggers this negotiation of water across the membrane.
Yeah, across the osmotic gradient. And that biological negotiation totally dictates tissue health. We look at this in three main categories. First is iso-osmolar.
Meaning equal. Right.
It means the product has an equal osmotic pressure to the body's intracellular fluid. So vaginal tissue naturally sits roughly between like 260 and 295 milliosmoles per kilogram.
Okay, 260 to 295.
Yeah. If a product matches that, the cells are stable. Happy cells. Nothing shifts. Then we have hypoosmolar products.
Hypo, so lower.
Exactly. Lower concentration of particles than the tissue. In that case, water actually rushes into the cells to dilute their internal concentration, which causes them to swell and potentially even rupture.
Oh, wow. Okay, so that's not great either.
No. But the major issue, especially looking at the data, seems to be the third category, which is hyperosmolar. These are products with a significantly higher concentration of dissolved particles than the body's tissues.
Okay, so using a hyperosmolar lubricant is basically like drinking seawater when you're stranded on a life raft, right?
That is a perfect analogy, actually.
Because you think you're getting hydrated, right?
Yeah.
But the high salt concentration actually sucks the existing water right out of your cells to balance it out.
Exactly. That osmotic drain is exactly what happens with hyperosmolar lubricants. The fluid literally draws water out of the vaginal epithelium just to dilute the product and reach homeostasis.
Which is just, it's crazy.
What's fascinating here is just the sheer scale of the disparity. Because, like we said, healthy vaginal fluids sit around that 290 mark, right? But many commercial water-based lubricants frequently range from 2,000 to over 6,000 milliosmoles per kilogram.
Wait, 6,000. If the baseline is around 300, 6,000 is just an absolute disregard for biology.
It really is. The WHO advisory note actually shows certain KY and Astrolife formulations testing over 5,000, with some even surpassing 8,000 milliosmoles per kilogram.
8,000? That's insane.
Yeah. So when those highly hyperosmolar fluids come into contact with the vaginal epithelium, which, remember, is the primary physical defense barrier for the microbiome, the osmotic pressure is so immense that it rapidly pulls the intracellular water out. The cells literally shrink, shrivel, and just undergo immense physical stress.
So you're basically applying a desiccant. I mean, it feels wet to the touch and it gives you that temporary slip, but on a microscopic level, you are aggressively dehydrating the tissue.
Precisely. You're pulling the water out of the very cells you're trying to hydrate.
And if someone is chronically using these to combat dryness, the tissue has to respond. It actually really reminds me of the rebound effect we see in dermatology.
Oh, right, like with acne treatments.
Yeah, exactly. If someone uses a super harsh salicylic acid wash or, spends all summer drying their face out in the sun, the skin panics. It overcompensates by overproducing oil, which just leads to worse symptoms for like 4 to 8 weeks.
Yeah, that mechanism, the body desperately trying to restore balance, is identical here. But the outcome is a bit different because mucosal tissue doesn't have sebaceous glands to pump out oil.
Right. They can't just grease themselves up to fix it.
No, they can't. So when hyperosmolar lubricants chronically drain water from those epithelial cells, the tissue shrinks, it thins out, and it loses its elasticity.
Here's where it gets really interesting, though, because, well, honestly, it sounds like a predatory business model.
It really does.
Because if you apply a high-osmolality lube to cure dryness, the lube dehydrates your cells further, causing a rebound effect of even more severe dryness once the lube wears off. So what do? You apply more of the same lube.
Yeah, it's a completely manufactured dependency. And the microscopic timeline of this destruction is it's alarming.
It's not something that takes years to happen.
Not at all. Histology reports using 3D cell culture models. They track this in real time. They found that a mere 4 hours of exposure to a hyperosmotic lubricant causes the actual death and sloughing off, like the shedding of those vaginal epithelial cells.
4 hours. That's like one evening. You use it once, and the top layer of your cellular defense is dead and peeling away.
Exactly. And the rapid shedding of these dehydrated cells isn't just about physical discomfort. It triggers a huge biological cascade that seriously compromises your immune system and your microbiome.
Right, because if you're killing that top layer, you're breaching the entire physical blockade.
Yeah, the breach of that epithelial barrier is a massive alarm system. Those dying cells, as they shrivel and slough off, they actually send out pro-inflammatory cytokines to the immune system.
So they're screaming for help, basically.
Basically, yeah. These signaling proteins flood the area, triggering inflammation, redness, and pain. And because you've removed that protected barrier, you dramatically increase susceptibility to infectious agents.
Because there's no wall anymore. The pathogens can just walk right in.
Right. The data shows this drastically increases transmission rates for sexually transmitted infections like HIV, chlamydia, herpes, and it severely destabilizes the microbiome, leading to bacterial vaginosis, or BV.
And this all comes back to pH, doesn't it? Because a healthy vagina is super acidic, right around 3.8 to 4.5.
Yeah, it's remarkably acidic, and that's totally by design. Those healthy epithelial cells, as they naturally mature and shed, they release glycogen.
Which is sugar, right, to feed the good bacteria.
Exactly. It feeds the healthy lactobacilli. And the lactobacilli ferment that glycogen and produce lactic acid, which keeps the pH low, and creates this environment where bad, opportunistic bacteria just can't survive.
But when that hyperosmolar product wipes out the epithelial layer in 4 hours, that whole cycle just collapses. The food source is gone.
Right. No glycogen means the lactobacilli starve. Without them producing lactic acid, the pH rapidly rises, becoming much more alkaline.
And once it's alkaline, the bad bacteria like Gardnerella or E. coli, they just take over the whole ecosystem.
Yeah, you've completely terraformed the microenvironment. There's a really eye-opening study on this involving TVUS transvaginal ultrasound patients.
Oh, right, where they use the standard clinical gel on the ultrasound one.
Yes. Researchers found that a single exposure to that hyperosmolar gel profoundly disturbed the vaginal microbiota, particularly in peri- and postmenopausal women.
And how long were they exposed for during an ultrasound?
Like maybe 10 minutes?
10 minutes. And how long did the disruption last?
Up to 9 weeks. A highly compromised, low lactobacillus environment for 9 weeks, just from a brief ultrasound.
That is deeply unsettling. But it also leads to a huge question about the regulatory standards. Because if a normal, healthy osmolality is around 300, and we know these hyperosmolar gels kill cells in 4 hours, why does the WHO advise that water-based lubricants should ideally be under 380, but they allow a liberal goal of up to 1200? I mean, isn't 1200 still super dehydrating?
It is. The 1200 limit is, well, it's a very frustrating compromise between biology and consumer behavior. The WHO set that limit to mitigate the most severe tissue damage, essentially to ban the 6,000 and 8,000 products that carry the highest HIV transmission risks.
But why not just cap it at 300 where it naturally belongs?
Because of the glycols. Manufacturers balance osmolality with glycols like propylene glycol and glycerin to make the product functionally slippery. Lubricants with low osmolality, which means low glycols, just aren't always as fun and slippery.
Oh, I see. So if it doesn't feel silky or if it dries out too fast, people just won't buy it.
Exactly. And if they don't buy it, they might have unprotected sex without lubrication, which causes micro-tearing and huge infection risks of its own. So consumers prioritize the feel of high osmolality lubes, totally unaware of the microscopic damage happening.
Wow. Okay, so what does this all mean for us? If chronic use creates this vicious cycle of dehydration and infection, how do you actually break the rebound effect and heal the tissue? We have to look at the difference between lubricants and moisturizers, right?
Yeah, the terminology gets super muddy here, but clinically, there's a critical difference. A lubricant is used episodically just to reduce immediate friction during sexual activity. It's temporary.
Right. And a moisturizer.
A moisturizer is used routinely, like 2 to 4 times a week, to actually change the fluid content of the tissue over time. They use ingredients like hyaluronic acid or polycarbophil, which physically adhere to the vaginal lining.
So they stick around and actually do the work.
Right. They deliver moisture slowly, they help lower the pH back to an acidic state, and over time, they restore the natural elasticity of the tissue.
So basically, confusing a lubricant with a moisturizer is it's like trying to fix severe dry winter skin by rubbing a silicone slip and slide on your arm instead of using a hydrating lotion.
Yeah, that's a great way to picture it, actually.
One just sits on top to stop friction, but the other actually enters the cells to heal them.
Yes. And speaking of healing, the research on hyaluronic acid HA is amazing, especially the work from the Jacob Klein lab regarding hydration lubrication.
Right, but they weren't even studying mucosal tissue at first, were they?
No, they were looking at healthy joints, like articular cartilage in the knees. They wanted to know how joints handle massive pressure with almost zero friction.
And it turns out the mechanism is super relevant here.
It is. They found that in joints, HA binds with these specific lipids called phosphatidylcholine, or PC lipids. When they combine, the lipid head groups become highly hydrated, surrounded by water molecules.
So they act like tiny fluid ball bearings.
Exactly. They provide incredibly low friction while maintaining hydration. And researchers realized that similar non-hormonal HA-based formulations can treat vaginal dryness safely without that hyperosmolar rebound.
Because it's actually locking the water in naturally. But what if someone doesn't need to heal chronic dryness, they just want episodic friction reduction, but they don't want the hyperosmolar damage?
In that case, silicone-based lubricants are a fantastic alternative.
Because silicone is anhydrous, right?
Right, anhydrous means it contains no water. And since osmolality is solely a measure of particles dissolved in water,
The osmolality of a silicone lube is literally zero.
exactly, zero. It has no osmotic gradient, so it physically cannot pull water out of your cells. It just sits on the surface, reduces friction, and doesn't dehydrate you.
That is so simple, but so effective. Okay, so just to summarize all this for everyone listening, the chronic application of hyperosmolar water-based lubricants doesn't cure dryness. It actively pulls water from your mucosal cells, triggering a rebound effect of cell death, inflammation, and worse, dehydration.
Right, it's a vicious cycle.
So to protect your microbiome and that delicate epithelial barrier, you have to seek out isoosmolar products around that 300 mark and really understand the difference between a friction-reducing lubricant and a tissue-healing moisturizer.
If we connect this to the bigger picture, really makes you think.
Yeah, how
Oh.
so?
Well, the sources show us that something as simple as the concentration of dissolved particles in a gel can completely alter the ecosystem of the human body in hours. It forces us to wonder, if this rebound effect is happening with intimate products, how many other everyday items in our bathrooms are doing the same thing?
Oh, wow. Like what?
Like alcohol-heavy mouthwashes or those redness-reducing eye drops that make your eyes clear for an hour but leave them feeling like sandpaper later? Are they engineered with osmotic imbalances that secretly perpetuate the very problems we buy them to solve?
Oh, man, that is a manufacturer dependency that is definitely going to haunt my next trip to the pharmacy. That's incredibly provocative. Well, thank you so much for joining me on this deep dive. And to everyone listening, keep asking questions, keep reading those labels, and stay insanely curious.